My name is Krzysztof, and I will be talking tonight about container types, especially about nested container types. So there's the special case that I would like you to discuss with me. And also that's why, because of this nesting, this talk has Matryoshka in the title, so this is the reason. So there are many things that I would like you to know about me, but the one thing that matters tonight is that I really love containers. I mean, like, I totally love containers. This is a mental model that really clicks for me. I really feel like it speaks to me. I can express the logic using containers way more easily than using other patterns. So that's why I'm talking about that, and that's why I'm so interested in them. But let's start with just making clear that we are all on the same page, and we know what we mean when we say container. So the container is just a wrapper around some value. And this wrapper itself, it brings also some special context, some special functionality, piece of logic that makes the whole reason why it does exist. Let's make some examples, because this is pretty abstract idea. The most widely known and loved container is, of course, the optional type, the one that has like a special syntax, sugar in Swift. And it wraps around some value, of course, and it gives this value a context of the possibility that it doesn't exist. So this is the context that I was meaning. The ability that not exist is the context that optional is given. And once you think about this in this way, it soon becomes obvious that there are so many other types of containers. For example, another one that is very popular is result. And this one gives a context that there might be a value or a possible error. Another one is either, which gives a possibility, the context for a value of being in one of two variants. Another popular one is future, which brings the context of the data not being available synchronously, but only asynchronously. And the last example is observable, the one that is very widely used, which gives you a value, a context of being a part of a sequence that is pushed into the observer, okay? And of course, there are many, many more containers, and I'm not even trying to make a list of them, and you can come up with the new ones, which is awesome. But what's even more important is to understand why those containers are so useful, why they're so cool. And the reason why they are so cool, because you can easily chain them. You can write some logic on the container in a pipe-like fashion, and it just works, and it always takes the context into consideration. So this is why the containers are so cool. Of course, this ability to chain containers is possible because of this great API that you can write for them. The most known method from this API is, of course, called map, and it just allows you to execute some logic on the value inside of container, keep an X context, right? The other well-known one is the for each, which is like a map, but it doesn't really wrap the result of the logic into the container. It just executes the logic. Then the other one is reduce, which is basically a way of taking the value out of the container. And if there is something missing that we need to provide so that the context is satisfied, then we need to provide this additional data. Like, for example, in the optional case, we need to provide the default value. And another well-known one is flat map, which is very similar to map again, but you are not really making the logic on the value, and just transforming the value, you're producing the whole new instance of a container. Okay. Again, this is pretty basic. This is pretty simple stuff, but I need you to get into this model of thinking about all those various types as the same category of types. And there are way more other functions that you can write on containers. And again, this is not the point to list all of them. What's most important is that they are so useful because they allow us to write complicated logic on some additional context in a very simple and consistent and declarative way. So let's go through one example. Imagine you've been given a story. This is a user story, and let's quickly analyze it and try to think of a way of implementing this story in a container-based way. So first step is just to fetch the data from GitHub, right? Then you need to deserialize this data, because this is probably in some binary form or JSON form or whatever. And then filter the results so only the Swift repos are left. Okay, these were the requirements. And once you write the logic in the container fashion, it becomes so clean and readable and declarative. You just state what you want to get done, and it's getting done. Unfortunately, this is all cool and clean and awesome only when you look from the distance. But when you look a little bit closer, containers do reveal some problems. There are some bad sides of them. And we can go to them by analyzing those steps that we've mentioned just a second before, one by one. So let's start with the first thing. We need to fetch data from GitHub. The GitHub is a web server, so we will be using the iOS URL session API under the hood. And looking at the basic URL sessions data task API, we quickly notice two things. First, it uses the completion handler, and also it uses this old Cocoa-based Objective-C related style of returning data or error via tuple of optional, in this case even triple of optionals. So we are all on the containers, so let's use the future instead of the completion handler, because this is how we express the completion handler in a container way. We just give it the container of a future type. And then let's use result instead of the tuple of optionals, because this is how we express the idea that something might be either a value or an error, right? So after this pretty basic analysis, our signature becomes a future of a result of either a data or a network error. Then let's move to serialization. So we'll use the Swift's codable API for that. But here is one twist that I would like to introduce. Imagine we need to know not only whether the data was decoded, deserialized in a proper fashion. We also want to know whether each one of the repos was deserialized properly. It's a little bit artificial, but it's not like beyond the scope of imagining. And also it's for educational purposes, so bear with me. What it means that we just need to deserialize in some sense twice. First, we deserialize just a data into an array of data, and then each one of these elements on the array will be deserialized into the repo. And for each one of those steps, there might be something thrown, right? So there might be an error, the serialization error. So the container equivalent of throwing errors is result. So let's use the result. And since we are throwing twice, we need to use the result twice as well. So as we can see, the signature after the serialization becomes just, it's like a nest of nested containers. It's becoming more and more complicated, more and more verbose. And if after we move to filtering, the filtering itself doesn't really make it any more complicated, which is cool. It's a crazy simple logic. We just check whether the property language on a Swift on a repo object that we have deserialized is Swift or not. But the whole idea of using containers was to just write this whole story in a very simple, concise, declarative manner. And how can we, having been given this madness as a result type of those two operations, just like make a filter on it? Like, how can you really filter something like this? I mean, something has gone totally wrong. Something has gone totally wrong, even though we tried our best. We really tried to apply as much of our knowledge of our love for containers to the logic that we were writing. And still, we got something that really makes it very difficult, that prevents us from working on the only one type, only one value that really matters to us, which is this repo, right? It's all down here, nested in all those containers. So let's try to fix it. First, I think the signature is way more complicated than it should be, of course. you can imagine that. And we can try to simplify this actual result of those two first calls using a few concepts. The first one is called isomorphic types. So sometimes there are two containers that are totally different, but they can really express the same idea. They can express the same meaning. The example, the easiest one that I could think of, is the optional of type A and either type A or void. So is there any difference, really? I mean, of course there is. These are two different types, but they express exactly the same idea of a value either existing or not existing at all. So we can just write transforms from one into another, and because they are isomorphic, as I said, we never lose any information. We can just transform them back and forth, and that's all. Of course, not all the containers can be easily transformed one into another, right? I mean, not all the types are isomorphic, of course, but sometimes those types do need to have some additional constraints, but still, it's pretty easy to reason about the situation when you can really do this transformation. And the one that we are interested in is transforming the result, the one that we've been using all along, into another container called validated. And validated is a very simple extension of a result. The result is just an idea that there is a value or one single error. And validated is an idea that there is either a value or one or more errors. So validated can just store multiple errors without any problem. So transform is clearly lossless because this way around, value becomes value, and if there is an error, it just becomes one error, and there are no other possible errors, but of course, it's totally lossless this way. The interesting thing is that if we were to transform the other way around, we would of course lose the information, because then we'd have to just ignore all those additional possible errors in the validated type. But fortunately, this time we are going only this way around. So once we apply the transform, all the results in the signature becomes validated, right? It didn't simplify the structure itself. The nesting is still the same depth and so on. But now we can apply the second concept. And the second concept is called sequence. And the idea is that you can sometimes, when you have a structure of two nested containers, write a logic that just reverse the nesting, reverse the order of those containers. It's pretty abstract, but the idea is that you can go from the container 1 of container 2 into container 2 of container 1. You just reverse them around. Let's look at the simplest example to make it clear. So imagine you do have an array of optionals. So there's this an array of either value or nil, right, in an array. And then for each one of those elements, you just iterate on them. And for each one of those, you try to unwrap and look whether there is a nil or a value. If there is a nil, the whole array just becomes like unusable for you. You just return nil for the whole thing. And if there is a value, you just store it in a non-optional form. And then if there will be no nils in the whole array, you just return the whole array. Very simple logic, and we have, just like that, really sequence, by using this sequence concept, reversed the order of containers. So we can easily apply the same concept and go from the array of validated types to a validated type of array of values. And I'm not providing the logic itself, it's pretty easy to write, but now, when we have that, we can really go into the final blow, which is the third concept called flattening. And the idea is that when you have nested containers of the same type, you can just flatten them into one container. And the easiest example, of course, as usual, is with arrays. So you can take an array of an arrays and just flatten them into one single array. But of course, you can also think of like an optional of optionals and a result of results and so on. And by using the flattening of the validated type, we can just go one level we can just get rid of one level of our nesting, which is pretty cool already. And we would really like to flatten more, but we cannot really because those error types doesn't match. But since we love containers so much, let's just use more containers to solve those containers problem. And we can wrap those errors into either container. And now the types match, which is, again, pretty simple to implement. Just make a function that maps over errors, not over value. And voila, we can flatten them again. And from this whole structure, we become really like only 3 level deep, which is still a lot, but it's way, way better than what we were starting with, right? So we managed to simplify at least a little bit. Is it enough, though? Just a quick reminder, we did all those transformations to be able to write this very simple filter function. It's all that we want, it's all that we care. But still, even after all those transforms, how can you write a filter, like a filter that is filtering a future of a validated of an array? I mean, it's still pretty cumbersome, right? But it is possible, and it's not really that difficult. And this is the other concept that I would like to talk about. This idea of writing like nested methods for containers. This is a concept that is sometimes called monad transformers. If you want to go into deep into the field, but for our purposes, it's just a way of implementing the operation when we have a structure of nested containers. And the innerMap, for example, so the inner function, is just something that can, having some structure of nesting of the containers, take a function that is doing some logic on this value that's inside those containers, and somehow be able to, keeping the context, I mean, keeping all those invariants that we're talking about, just apply it all deep down, not just map over the first container, but map over both containers at the same time, right? So this is the idea. There are 2 ways of writing those nested methods. One is protocol-based, and the other one is method-based, and I will just go through them quickly one by one. The first one is like the inversion of type erasure. You are probably already familiar with type erasure. Type erasure is a way of taking the protocol with associated type, this very difficult structure of Swift that always prevents us from getting them into the arrays or into the properties. So you go from this protocol of associated types into the structure that has the generic parameter. And this generic parameter is like corresponding with the associated type in the protocol. And what we want is to go exactly the other way around. We do have a container that is generic, and we want to create a protocol with associated type that corresponds to this generic parameter. So basically just an inversion. The process takes 3 steps. First, you need to create the protocol, of course, to have it, and create all those associated types. The same associated types, the amount of associated types here corresponds to the amount of generic parameters in the type. And of course, you can also implement this protocol in the container. The second step is you want to expose all the methods that you are interested in, so the methods that should contribute to being the inner methods, let's say, into the protocol's API. So you basically just copy-paste and duplicate the API. And the last step is to create a constraint extension. So once you have this type, and this type is providing a method, you can just write an extension on any other container that uses this method that you have, duplicated in the protocol's API, and use that and delegate the mapping inside. So basically, now you have this special variant of map that makes it possible to map over values that are in a nested structure of a future inside of a future of validated of A. And that was the first way of implementing that. The other one is called I call it method-based way. And it's even simpler because we are not really making any protocols. We are not really making any new special, someone got excited, any new special structures. We just add all the constraints to the method itself. So first, you just write the regular extension, not constrained at all, and you just duplicate all the generic parameters from the nested container into the generic signature of the method, right? You have as many here as you had in validated, plus, of course, any other ones that you need. You just provide the logic that you are writing. And then, once you do have all those generic parameters here, you can just use them to constrain it directly. And it works. No validated types, no special protocols, nothing. It just works. You can just write a nested logic inside here. And knowing those two methods to write the nested filtering and the nested container functions, we can write a nested filter. And it's really not very difficult. There might be some boilerplate to write if you go with the protocol method or not. But after a very small amount of code, you can just write the filter and provide it with a closure that takes the repo object directly and returns bool. And even though it's down here, it just works. It just works how it should. So we can get back the chainability and the declarative way of writing that we were so that made the container so awesome in the first place. And the sad thing is that for each combination of the nesting containers, you will need to write separate implementation of those functions. So you will need to write a separate filter for an array inside the future, and a separate filter method for an array inside the result, and a separate filter method for an array inside an optional, and so on and so on and so forth. So what can you do with all this boilerplate? How can you reduce it? Well, of course, you can just write it, and if you stick to a few situations that you really need it, from my perspective, from my experience, I usually had to write only like few of those, maybe 5, maybe 6 special combinations of nested containers, and it took care of the places that I was working with. But if you have a lot of boilerplate, of course, the best source for boilerplate is always code generation in Swift. We don't have any other really. And you can do it using sorcery. And there is a whole talk from last year by a guy called Elviro Rocca, who is an awesome Italian developer, very interested in functional programming, that gave like a half-an-hour talk about exactly this, writing templates, generating all those nested methods, so you can work on the containers easily. And the other solution, you can always just retreat into types, the container types, that are way wider. So we are using a dedicated container for each concept that you want to express. Asynchronous operation, future, error, result, and so on. But there are some containers, like Observable, that can really express a lot of things at once. For example, Observable can express the asynchronous operation basically as in a very similar and as well way as the future. And Observable can also return error, which is basically the equivalent of a result. And the observable is a sequence, so it can also express the array. So basically this whole thing, with a little bit of the information loss and a little bit of different structure of operation, could have been just expressed with a single observable. And I think this is one of the ideas behind the reactive programming and the concept of observables, of signals, that made them so popular, because they just get rid of all those nuances and all those needs to clean up the container structure. Anyway, that's pretty much all for me. I mean, the talk was about nested containers, so this is what you get. I hope I gave you some ideas on how to work with some issues when you encounter a container nesting. And having that, I feel that you might feel in the nested containers just at home, like here. So thanks you very much. And I'm happy to answer the questions. Thank you.
Have you been using observables yourself in your projects? I've been using RX Swift. What do you think about it? Like, what's your experience with RFP?
Yeah. RFP. Yeah. So basically, I was using RX Swift for like 2.5, maybe 3 years, almost all the time. So I had a lot of experience with that. It's an amazing tool that you can really shoot yourself in foot with. It takes some consideration to think of the best usages and the best practices of where to use the observables. Sometimes they can just pass the information in a way that is pretty much very similar to the old notification center style macaroni applications. But if you use them sparingly, and if you use them knowing what you do, and if you think about nice patterns, and also use all those traits that express some more information about, like that the observable can only return one value, or that it never really errors out, and so on, it becomes way simpler. The main thing that the main issue that I grow to have with RX Swift that makes me look into reactive Cocoa more is that I think that it is a design mistake after all to not include the error type into the signature of an observable. But yeah, this is of course a very conscious design choice on the RX Swift designers and developers, and of course they had their reasons. I just grew to not always be. Yeah, I just encountered enough problems with that, enough bugs with that. So I feel like this is one thing that I could change. But definitely, yeah, I really encourage everyone to just at least try, and maybe not go like totally crazy and not use observables all the time, but at least in some as a replacement for some delegation or completion block patterns, like communication patterns that are really like code heavy, because it's really way easier to just expose a few observables and to pass information from the observables than the usual way of one-to-one delegation that if you have like a layered application and like 4 layers of the logic, sometimes you just write the delegate after delegate after delegate after delegate. That's just passing information, and it's way easier to just use observable then.
Have you tried to use the mapping and transforming the containers with free function style?
Oh yeah. So yeah. This is something that I know, Kuba, you are very interested in. I saw your talks and I read your articles, and I'm also very interested in it. I still feel like totally novice in this area. I'm really interested in those ideas. I'm interested in the ideas that are being preached by guys like those two, yeah, Brandon Williams and Stephen Salis, so the guys behind the Point Free website. I think there is so much potential in it. I still do not feel like I know always where to use it. And yeah, so in production, I haven't really like based my application on free functions and the functions composition. I still don't feel like I can recommend it in my team, for example, saying that, okay, if there will be any problem, I am the person that will always come up with a solution. I don't feel that experience with the area, but I'm definitely trying to learn as much and thinking about that in the future. Okay, so if there are no more questions, I'm very thankful for your attention.